Well, thank you for joining us, everyone. As mentioned previously, I'm Youssef Alfaham, Technical Marketing Manager at Autodesk, and with me today is Ryan Brown, Technical Solutions Engineer at Autodesk. And our topic for today is Holistic Wastewater Collection Modeling using InfoWorks ICM. Going to transition to the next slide. Before we get into the topic, before we get into the content, safe harbor statement. We're just going to mention to you that if any one of us mentions anything, any forward-looking statements pertaining to any of our solutions, we do not want you making any purchasing decisions based on those statements. So that is pretty much the summary of this entire slide, and that transitions us to our agenda for today. So we're first going to introduce InfoWorks ICM. Some of you may have heard of it, some of you maybe haven't. We're going to tell you what are some of the unique capabilities in ICM, and then we're going to dive right into wastewater collection modeling and cover sequentially from network creation to model calibration to analyses and output generation. So this is typically the logic behind a typical wastewater collection modeling project. We're going to wrap up with some resources and then Q&A at the end. So InfoWorks ICM, it's fitting to discuss ICM in the context of Autodesk Water portfolio. So primarily, we're split to desktop solutions and cloud solutions. In desktop, we have water distribution, wastewater collection, stormwater and flood, and in cloud, we have asset management and operational analytics. For today, we're going to be talking about wastewater collection, and more specifically, urban scale wastewater collection, which is using our solution InfoWorks ICM. So what is InfoWorks ICM? Actually, the main question always is generally asked is, what is ICM? What does it stand for? So it stands for Integrated Catchment Modeling. It allows you to model river, urban drainage, and overland flow and conduct hydrologic and hydraulic studies or assessments. Why InfoWorks ICM? As you might be familiar, in a modeling project, it's generally beyond a modeler or multiple modelers or multiple team members trying to work and leverage the same model. So one of the unique capabilities of InfoWorks ICM is the workgroup database. Historically, we've been positioning the on-premise workgroup database, which pretty much works as follows. You have a central data hub with a master model or a master copy of your model. It is up to date, and you have multiple users being able to access that central copy of your model. And in the events where you have, let's say, an element that was edited by two different users, then there's a clash or some sort of a conflict. ICM is going to flag that and tell you need to resolve the conflict before you can proceed. So it simplifies this collaborative environment between your team members as you're trying to work and access the same model. So that's been I guess historically, what's been positioned. And in recent years, it actually transitioned to a cloud. I'm going to call it a cloud workgroup database. So it's similar to what I described in the previous slide, except you don't need the on-premise IT infrastructure like you would have needed with the on-premise database. So that takes us right into our topic. So wastewater collection. This is going to be an engaging session, so we're going to ask you quite a few poll questions, and we would hope for your participation for us and engagement with us, so we can get right into our first poll question, which is going to ask you, what is your current solution for wastewater collection modeling? We're just going to give you a few seconds. There are 4 options: InfoWorks ICM, InfoSewer, InfoSwim, XPSwim, competitor solution, or we do not perform modeling. Thank you for responding. Please continue the responses. Seems like, for the most part, let's see what's leading right now. It's between ICM and we do not perform modeling. Actually, we do not perform modeling is dominating to an extent right now. And we're going to give folks just a few more seconds, and then we're going to transition to our next slide. Okay. So the responses, most of the attendees use ICM, and then the other majority do not perform any modeling, and we have some folks using InfoSewer, InfoSwim, and XP, and then some using competitors' modeling solutions as well. And that is a good segue to our next question, which is what is your preferred modeling solution for wastewater collection? So some of you may be using something, but maybe you'd like to use something else, and that's really the driver behind this question. So we're just going to give folks a few more seconds. And obviously, if you don't perform any modeling, you might aspire to use something, or maybe you know do not know yet. Okay, so responses are still coming in. We're just going to give folks another second or two. All right, we can end the poll there. So majority of you have responded that you'd prefer using InfoWorks ICM, which is great for us to hear. And hopefully this presentation is going to, uh, motivate that or continue to lead that. The final poll question before we kick this off is, what is the biggest pain point to those that perform wastewater collection modeling? What is the biggest pain point in your present wastewater collection modeling workflow? So is it in the network creation segment, or is it in the model calibration, or is it in the analyses or output generation? Just going to give folks a few more seconds. It seems like most people, the biggest pain point for most is typically in the model calibration based on the responses that we're getting. And we're just going to give you a few more seconds. All right, we can go ahead and close the poll. So yeah, most respondents have highlighted model calibration to be the main pain point in the wastewater collection modeling workflow. So thank you all for engaging with us. This takes us to our first pillar. So as you've noticed from the previous poll question, we've segmented the webinar to 4 primary pillars under wastewater collection. The first one is going to be network creation. The second one is going to be model calibration. The third one is going to be modeling analyses, and the fourth is going to be output generation. And the PowerPoint is going to progress in that same sequence that we highlighted in the previous poll question. So with network creation, the first thing that comes to mind is leveraging ICM's Open Data Import Center in order to bring in your node and conduit shapefiles and then map those accordingly. So what you're seeing in this short video here is how easy it is using the Open Data Import Center to bring in your node shapefiles and map them, the object fields and the import fields, and then doing the same for the conduit. And once you have that shapefile, you bring it in and then you map it again between the object field and the import field. And it's, however many clicks those took to be able to import your network conduits and nodes and other features that you might have existing. And then from that, you might be interested in bringing in some other background layers or GIS shapefiles, such as parcel data that you can bring in through the GIS layer control within InfoWorks ICM. And on top of that as well, some people prefer accessing models with web maps. So you also have the ability to use ICM's GIS layer control to bring in a web map server, a web map using a URL. And you're going to see when you confirm, it's just going to load up in a second or two. And that's pretty much the process to go from a blank ICM sheet to a network with your nodes and conduits and backgrounds and parcels, etc. And typically, after you've created your network, there's going to be a desire to know where my data gaps are, because typically during the import process, not all data is going to be complete. And ICM provides you the ability to, and I'm going to pause here for a second. The ability to validate your network once you've brought it in and you have color coding that kind of highlights what you need to pay attention to before you proceed to the next step in network creation or in validation. And one of the key things, or one of the unique things about it, is once you've validated your model, you're going to see this, the code at the bottom where it's saying, there's a node that's missing ground level. If you click on that element in the properties, it's going to have this inline validation color coding that's going to highlight immediately to you what you need to populate instead of having to search where the ground validation is. So I think this is, in my opinion, a pretty unique and streamlined process for validating your network and being able to visually identify where the gaps are. The next thing we're going to look at is being able to plot a profile and once again highlight that there are obviously some funky things happening in this long section or profile, including maybe some incorrect or missing invert elevations. And what you're noticing here is, once again, you're clicking on this element in the profile and you're seeing the inline validation color that's indicating that you need to input this number into ICM. And so the thing about it is data typically in the upstream process of importing your network is never going to be fully complete. And ICM actually provides you with the ability to automate the filling of that missing data instead of having to go into each missing conduit or node and input those manually. So ICM has an inference feature that, as a reminder, this is the profile that had missing data in it. So what you can do is you can certainly go into each of those missing data points and populate those numbers manually. But with ICM, what you can automate that process and use the inference feature to ask the software to populate missing conduit and node data. And I'm going to pause here for a second and also be able to flag that data. So what you're seeing where the mouse is right now, you're seeing flag inferred values. So it's going to, any data that the software changes using the inference feature, you're going to be able to identify that easily with a data flag. And you're going to see that towards the end of this video. So how does it work? It's as simple as drag and drop the inference feature into your network and it's complete. And what's the proof that it's been completed? Once you validate it, all the red flags have been gone. And you're going to plot that long section again, and you're going to see how it looks in just a second. And there you go. None of the funky, looking inverts or missing elevations. And that's the data flag that I was referring to. You're seeing this INF, which indicates that this value was populated through the inference feature. And a cool thing about data flags is actually, and this was a neat video that Ryan had created. What he did here is he changed the data in that field, and you're seeing that the flag automatically changed to, and it updated from INF, which means it was an inference data input, to RFB, which is Ryan's initials, meaning that he updated that or he input that. So that's one of the unique things about ICM is just the ability to track where your data came from. Was it imported from your shapefiles? Was it updated through an inference, or was it manually updated by a user? So far the sequence that we've progressed in is building or creating your network, validating your network, and populating your data gaps. Now, assuming you already have a network, that let's say there's a development or a project that's happening or that's getting built in your in your system, and that development they're using Civil 3D to build their network, preliminary network. There is an integration between Civil 3D and InfoWorks ICM where you can bring in through an add-in ribbon within Civil 3D, you can bring in a pipe network that you've built out in Civil 3D into your InfoWorks ICM network or even a blank model. So what you're seeing here is you do have a pipe network in Civil 3D that you're gonna, there you go. If I pause here for a second, on the top left-hand side, this is under an add-in. You have the import export between Civil 3D and ICM, and this is built in. You simply just need to download the add-in, and this is going to be built into Civil 3D. So not a lot of manual workarounds between like exporting and importing, etc. This is going to push out a CSV file, and then you can go to your ICM and bring in that CSV file from Civil 3D. And you can do similarly going from InfoWorks ICM to Civil 3D. And the idea is any development that you have happening in your system, you can build out that network in Civil 3D and bring it into ICM and run the analyses and validate it, and maybe change diameters or change profiles, etc. Finally, after you have a completed network, the logical next step becomes, your dry weather flow diurnals or your diurnal pattern. So in ICM, you have the ability, the streamlined ability to do that. In this short video, we're going to show you how you can set up a dry weather flow for a residential diurnal, and you obviously can create as many diurnals as you would like. You're going to see the profile number associated where it says here profile 1, that is going to be associated with the diurnal that you're creating. And the reason that is important is because when you're assigning diurnals to subcatchments, you're going to be assigning it based on the profile number and not based on this description that you're inputting. So this is an example where we're setting up a residential diurnal profile, and we have the data in an Excel spreadsheet, copying that and bringing the factors in. You're going to see the graph update accordingly. And you can create as many diurnals as you'd like and assign them to the appropriate subcatchments, as we're going to see in this video. So we've selected our subcatchment, and you're going to see in the properties, there's your wastewater profile in the diurnal associated with it. So it's not going to mention the description in there, but it's just going to mention the profile number. The other thing that comes after you've developed your network, maybe you've validated it, you've used the inference tool to populate missing data, you've maybe brought in a new network from Civil 3D, and you've input your diurnals, you might want to set up your rainfall events. And how you do that, we have two videos that demonstrate. You can either set up a custom rainfall event or a user-defined rainfall event, and in that case, it's not going to be a design rainfall, so you're going to uncheck that, and you're going to populate your user-defined rainfall event accordingly. We also demonstrate in the second video how you can set up an SCS design rainfall event. So you have a long list of events that you can choose from. Here we selected SCS, and then you're just populating the characteristics of your rainfall event, clicking OK. You can even graph that to take a look at it visually if you would like. Similarly, you can do the same thing for a NOAA Atlas 14 rainfall event, and that's what's going to be shown here in this example. And you're going to use the rainfall generator to get that data, import it into ICM, and you're seeing all the data here. And you also have the ability to graph that data. So what's being demonstrated is just the flexibility of the number of options you have to set as you set up your rainfall from user defined to the various design rainfall options. And that concludes our brief overview of the capabilities of ICM in the network creation. And now we transition to model calibration, which I'm going to pass on to Ryan for him to cover this portion.
Yep, thanks, Yusuf. You hear me all right?
Yep.
Great, cool. So yeah, InfoWorks ICM has a time series database integration. This is really a very, very neat thing in terms of being able to directly link into things like SCADA data. This is really the first step in transitioning a model from something that's just used for planning into something that could be used for live modeling. So that time series database we were looking at the beginning was a series of different flow monitors and level sensors and things like that. For this particular case, I know that there is a flow meter on this pipe, and so we can see overlaid the observed value there in that kind of reddish color, and then the model data in the reddish color, and then in the goldish color, the observed data, how well those are matching up to each other, the volumes associated with how much volume is within that based on the flow, basically area under the curve kind of thing. We can also look at scatter graphs, export these out into CSVs, and do further statistical analyses if we wanted to, stuff like Nash-Sutcliffe and other things like that to make sure that you are seeing a nice one-to-one relationship between those observed and predicted values. And being able to streamline that process and really more often be able to calibrate the model rather than doing it just every couple of years or so. That is a little bit advanced, you could say, in some cases for some utilities or some organizations that maybe they just don't have a lot of growth in their system and really don't need that direct link into their SCADA data and having to calibrate much more often. The option there is a fairly similar idea, but the setup is a lot less complicated where we're using flow survey data. So these flow surveys can include things like observed flow like we're seeing here, but also level information estimation, and then a rainfall event that would be associated with that time period that the observed event is taken on. So instead of having the time series database in the run, we are just going to use the flow survey in that run and then run the simulations. And after that completes, it's going to look fairly similar to what we were seeing before with the time series database integration and being able to display the observed on top of the uh, predicted or the modeled data. Um, Also, a pretty key thing is to be able to use SQL queries. So SQL queries can be used for just about anything from editing the model to looking at results. These can be particularly useful in cases of calibration, just because it does lend itself to do things like adding scenarios like we're seeing here, or increasing or multiplying against different factors. So you can see here I've added those scenarios using the SQL query, but it's all just a copy of the base. And as we kind of progress through here, being able to update the population of each one of those simply by multiplying a factor against them. I've also used these in cases of modeling um, river sections and things like that, just by being able to have a multiplication factor against that. You can also use these in conjunction with results data. So referencing something in the results, if there's a particular metric you're trying to meet, and you say, I want to make sure my V over D is this, and if it's not, then I want to increase the pipe by 3 inches or something like that. You certainly have the capability of doing that with SQL queries, instead of having to necessarily manually go through and figure out matchup between the model and the results and all that kind of mess. Yeah. Okay, there we go. Also, it's not that new now. I still kind of consider it new, but it is something that we have rolled out, and it is available with any InfoWorks ICM license at no additional cost. But it's to be able to run simulations in the cloud. In this particular scenario, I have a NOAA ensemble of storm events. There are dozens and dozens within this file. And the idea here, maybe we're running some Monte Carlo um, climate change types of things, and we're trying to, and we're running, you know, hundreds, if not thousands, of simulations trying to get an idea of what things look like. For a 1D system, and I kind of get to this a little bit later, for a 1D system, it's not necessarily as impactful if you're just running one scenario, but if you are running multiple scenarios, as you can see here, it is pre-processing and then uploading to the cloud. But all these simulations are run in parallel. So instead of like on a local computer or a local server, having the hardware there and running each simulation one by one, we're running all these in parallel. And so instead of going one by one, which would take something like 4 hours, this particular instance took 6 minutes to run all these different scenarios here. I think that's about the end. There we go. Yeah. So I did do a little bit of testing, like I mentioned, for one-dimensional systems. This is a fairly simple. I think it was like 800 pipes or something like that, and typically only takes a couple of minutes to run. But I ran 1,000 simulations, and as you can see here, included in that cloud runtime is the amount of time it would take to upload and download results too, just to make a fair comparison. But not huge there. But if we look at the 1D, 2D analyses, we have some really great hardware that we're using on the cloud. GPU cards can be leveraged for the 2D computations, and because of that, the better GPU card that you got, the better it's going to go. And so, as you can see here, 3,600 simulations in just over 2 hours, and I tried doing the same thing on my local computer, ran it overnight, and just gave up after 17 hours. Um, Based on the progress, it probably would have been something like 24 to 30 hours. But yeah, pretty impactful things there. We've also even had clients going to on-prem into the cloud and seeing what kind of benefits they have. They had 6 modeling solutions or simulations, and they were taking a couple hours each. So running those all individually, they had 6 times 12 or 6 times 2 equals 12. After moving to the cloud, they were able to run all those in parallel, not to mention being able to leverage all that nice hardware and not having that IT overhead. It took about 2 minutes for them all to run, really impacting the efficiency on that project. And modeling analysis. This is you, right?
Yeah.
Yeah. Okay. I'll hand it back over to Joseph.
Awesome. So just a quick recap before we I guess progress forward. So far we've covered the sequentially going from network creation to model calibration and what some of the unique capabilities in ICM that exist from what Ryan just mentioned, from the time series database to cloud computing. That's the intent, and that's what we intend to cover in this PowerPoint, and we continue to cover. So far we've done network creation, model calibration. Next we get to modeling analyses, but before we move on, just some more engaging poll questions. So a question on steady state and EPS runs. So do you predominantly utilize steady state runs, extended period simulations, or is it evenly split between both during your analyses? So do you do steady state primarily, or EPS, or both? We're just going to give folks a few more seconds to answer this one. Okay, it seems like most people are evenly split between both, with a close second EPS, and then a good number of people primarily just do steady state. And that takes us to our next question. People that just do steady state runs, which of the following do you perceive to be limitations of steady state runs? Sorry, which of these limitations would you perceive compelling to transition from steady state to EPS? So people that just strictly do steady state, do you perceive any of these limitations that we highlighted there as compelling to transition to EPS? And we're just going to give folks a few more seconds to answer this one. Seems like a good split between all of the above, and that it's a snapshot in time and not dynamic. Okay, final question. People that strictly do steady state, what might be limiting your adoption of EPS? Do you think is it the absence of EPS capabilities in your present modeling solution? Is it the number of required inputs? Is it the perceived complexity of EPS, or is it the perceived adequacy of steady state? So we're getting a lot of inputs on, a lot of respondents on highlighting that the number of required inputs of EPS is what's limiting their adoption, and also the perceived complexity of it. Okay, so poll questions aside, thank you all for responding to our poll questions and engaging with us, and really giving us your thoughts and feedback as we ask those questions. As a reminder, in this section, we're going to be talking about the modeling analyses. So after calibration, you might want to start running some analyses. There's a lot that you can do. We broke it down into planning, what you can do with ICM from a planning standpoint, what you can do from a design standpoint, and what you can do from an operations standpoint. So from a planning standpoint, the first thing that comes to mind is being able to leverage the total storage dialog to identify in your network the static, live, dead storage. And as we're playing in this video here, the value of that is being able to potentially, in the planning phase, identify where you might have measurable or significant dead storage, which might contribute to something like H2S formation. And you're seeing how simple it is to identify, again, the static, live, and dead storage. And in a second, what we're going to show is, after you've run that total storage analysis, you are going to have the ability to go to your results table and identify here. So this is, oops, apologies, I went too far ahead. So this is going to be the column that's showing you the debt storage. We're going to sort that by ascending. So you're going to see the greatest values up top, and sorry, descending. So you're going to see the greatest values up top, and then you're going to highlight the conduits in your network that have measurable debt storage, and that would allow you to detect things like this, which is going to pop up in just a second. Things like this in your network, which might be limiting the draining of, areas of your network. So that was the first case that we identified in the leveraging of ICM for planning purposes. And granted, this might be a simplified example, but the point is applies throughout. The other thing we wanted to cover is modeling to streamline design. So surcharge and scripting. This is an example of a network or a long section where you're getting surcharging, and that's obviously problematic. What you could do manually is through iterations upsize pipes accordingly and resolve that, which might take you, depending on your experience, it might take you a significant amount of time. Instead, what you can do is two things: either scripting or SQL. In this video, we're going to cover scripting, which might sound overwhelming, but it's maybe not as overwhelming as we make it to be, and I'm going to explain why in this short video. So the first thing is, after you've noticed that they're surcharging, you might be interested in identifying the pipes that have a max surcharge state of either 1 or 2, depending if you're looking at surcharging by depth or by flow. In this example, we're strictly focusing on pipes surcharging that have a max value of 2, and you're seeing there's quite a few of them here. And so the iterations to change that or to upsize pipes in order to get them to a lower value than 2 might be, again, quite a bit of effort. So what you can do is, and this looks overwhelming, but we're going to get to our script and we're going to explain it. So here, this is the script of interest right in the middle of your screen here. So what we're saying is that in the script, if there's a max surcharge of 2, then if it's less than 2, then nothing to upsize. But if it's greater than 2, then we want to upsize the pipes based on certain criteria that we've input in the script. And the convenience of it is you're also going to be tracking through version history. You're going to be tracking all the iterations where the model had upsized the pipes incrementally, and that's what you're seeing here. So every single increment or every single version here, you're seeing that each scenario represents an upsized pipe based on the script that you ran. And when you get to the final scenario, which you could select to obviously validate that the script is giving you what you needed, you're going to run that final scenario and you're going to view the results and plot the profile. And keep in mind, early on we were looking at a long section that was just surcharging throughout. And after we've run the script, we're going to look at our long section again. And you're going to see it's no longer surcharging. The idea is things that you could have done through many iterations manually.
Just to add to that.
Yes, go ahead, Ryan.
Oh, okay. Yeah, just to add to that, basically what that script does is just loop through and continually run the model. We did get a question that I feel like is relevant. We could go ahead and answer, but how do you run a script in ICM? So the language is called Ruby. We do have GitHubs and things like that to be able to leverage, but it's just a matter of, well, no, I forgot, but it's, I believe it's a file. And then put it up right now. I guess keep going, and then I'll come back on and answer.
Yep. So as Ryan highlighted, that's the surcharge state and scripting. Now you can do something similar along those lines with SQL queries in ICM. So the idea here is, again, same to the previous example where you have the surcharging state, but you would like to update the conduit size or the conduit width based on set criteria, and you're immediately probably noticing that SQL seems a little bit simpler than the previous example. And what we're saying here in this SQL query is that you identify the max surcharge of greater than equal to 2. If the conduit width is less than 17, then you update the conduit width by 3 inches. And you're also going to flag that data update with a flag called SQL or SQL. And then, in addition, if the max surcharge is greater than or equal to 2 and the conduit width is greater than 17, you're going to update the conduit width by adding 6 inches. And you're going to also flag that as SQL. And then finally, there's this neat thing that Ryan added in there, which is we're asking the software to push out a CSV file with all the information of the updated elements in the network. So probably a simpler interface than what we covered previously in scripting, but both options are there for you. And the idea is similar, is that all these stats that you would have to do multiple iterations on and do a lot of manual checking and going back and forth and adjusting and creating scenarios to check and looking at version history, etc. You no longer need to do that with things that might automate that process using either scripting or SQL queries. And probably one thing that's worth mentioning is the SQL queries, once you've created it once, you can use it across multiple networks. You can share with multiple team members and colleagues and use it accordingly. So the transition so far, the sequence so far has been in modeling analyses, looking at how you can use ICM to support you in the planning phase by maybe identifying static, dead, and live storage and mitigating the formation or limiting the opportunity for H2S formation due to dead storage. We've also looked at modeling to streamline design using scripting and SQL queries to eliminate the multiple iterations that might exist in a specific workflow and overcoming that. The final example that we cover is modeling to support operations. And Ryan touched on that a little bit during his segment when he was talking about time series database. But in essence, what we're talking about here is using forecasted rainfall data and bringing that into ICM through the time series database to be able to predict or forecast how your system might respond in the event or due to that upcoming rainfall or storm. So the key there is being able to be proactive in maybe having a response or an operating procedure in the event that the storm comes. We're going to do these steps to mitigate maybe an SSO or a CSO event. And that applies across the board for forecasted events. In addition, as Ryan highlighted, with time series database, you also have the ability to input observed data for maybe looking at past events and how your system behaved in past events. So that's the unique thing about time series database. And Ryan talked about the live connection, but in this, we're talking about maybe having observed data that you're using to input into your model and seeing how your system would respond to that. So that concludes our modeling analyses portion, and then we transition to output generation, where Ryan is going to cover this final piece here.
Yeah, and I think I'm having a little bit of connection issues, so I turned off my camera to maybe help. Are you hearing me all right?
Yep.
Yep, okay. Yep, so in the output generation, we have things like, yeah, things like the 3D view, just being able to visualize things and make sure that things are how you think they should be. Looking at bridges this way, looking at the trains is an exaggerated look. We also have other options for being able to look at the. I'm actually. Hold on one second. Should be a better connection. Hit the next one.
Do you see that?
No, it's not refreshing for me.
Okay.
I'll just, yeah, so we got the 3D view. We've also got thematic mapping. So with the thematic mapping, just being able to save those and then drag and drop so you can kind of create libraries of these and be able to um, highlight things that you might often want to see or in particular ways. Of course, you can right click and customize those as well with the properties menu and all that. Next up, there is profile views, plan views, as we're seeing. All that thematic mapping matching up between the profile view and the plan view. Tabular results can also be pulled as well as graphical results. Um, Next up, looking at some of the reporting features you can utilize SQL queries for. So building customized tables, highlighting where certain issues might be going on. Again, really, really flexible, not necessarily complex, certainly not as complex as some of the scripts we saw earlier. I know it's not pulling up, but these are relatively simple, like one line kind of things. And again, that GitHub source is kind of chock full of these. And then, these factory, ICM factory SQL queries, it's not built into ICM, but we're certainly happy to share this kind of general list of some of the common things that users might want to see and use it as a starting point to be able to write additional scripts. And with that, I'll
Awesome.
hand it back to Joseph for the resources.
Yeah, awesome. So we're right on time. We probably just have about a minute or so. And for resources to wrap up, the two things we want to highlight that we have on-demand training for InfoWorks ICM that you can access through the Autodesk website. It's about 6 hours. It has a data set and a video that you can follow along with. In addition, we have kind of deeper trainings that are shorter in length and they're more specific about certain topics that you might be interested in. And finally, we just want to highlight our One Water blog where we have a lot of content that we put out into our blog pertaining to ICM, transitioning to ICM, some case studies, some thought leadership conversations, and sometimes we put in some workflow videos as well. So that is the end of our presentation, but we did have a final poll question that we're hoping you can engage with and let us know your feedback. So the final poll question is, would you like to be contacted by a product expert for a demo? That poll question should show up shortly. If it has not, is the poll active or not yet? No, the poll. Can we activate the poll? All right, just give me a second.
Give me just 2 seconds and you should be able to see it in just a moment.
I guess while we're
Aha,
waiting, maybe
here it
we could.
is.
There it
Okay.
is. Okay, it should. Okay. All right, so if you could please respond to that poll question if you'd like to be contacted by a product expert for a demo. And we're just going to give folks a few seconds to respond to that given the delay. Apologies for that.
And we'll just keep it open.
Okay.
Yeah, so did we want to go into some of the questions here?
Let's see.
Yes, if you'd like to go through Q&A, you can absolutely do that. We'll leave that poll question open until the end. If you'd like to go ahead and select yes or no. And Yusef and Ryan will go ahead and answer some of those Q&A that's in the chat.
Yeah, I literally have a fire alarm going off in the hotel I'm in, so hopefully that's not too distracting. I don't know if it's audible at all, but we've got the first question. Is there an efficient process for importing open channel networks from GIS? For example, having the top width, bottom width, and channel, there we go, it's off now, bottom width and channel depth of a trapezoidal channel. Unfortunately, no, and it kind of depends on whether you're looking to incorporate it into just the 2D surface, or if you're trying to build an actual like river reach type of thing. We certainly have open channels within InfoWorks that you can define just the trapezoidal channel in a 1D sense, in addition to a true river type of system where it would be more like heckgrass, and we do have an importer for heckgrass as well, the geometry at least. If you wanted to incorporate something like that into the 2D surface, you could certainly bring those in as break lines and have that top width and or have those lines for the tops and bottoms defined in there and bring those in as a break line so that you'd be able to utilize those like spaces, and once you go through the meshing, being able to have that. Got a question on limitations for the cloud simulations in terms of storage and runtimes and things like that. I did put in the chat some more information on that, but just to kind of follow up on that, there is no limitation currently on storage or the number of simulations that can be run. But really, really good to hear that it looks like that same person, Alex, had a client running 3 days on their local computer and cut that down to 4 hours in the cloud. We also got a question about calibration parameters. In this particular presentation, we didn't really do calibration per se. Things that you might want to look at for calibrating a model depends on what type of model it is, if it's a stormwater model, if it's a 2D model. But commonly the things that get tweaked are things like mannings, roughnesses for pipes or for surfaces. You might also need to tweak things like weir coefficients or orifice coefficients based on that observed data. And then also if it's like a wet weather analysis and you're trying to calibrate wet weather flows, incorporating, I guess, depending on the module that you want to go use, the more common one being RTK, you would adjust those RTK parameters. Running a script, I did end up finding out where that is. It's in network, and about 2/3 of the way down, there's a run Ruby script option where you would just navigate to that .rb file. If you are looking for a software to write any of those scripts, I know there's Code Writer is a freely available one. So are some options for that, being able to pull that in. And again, I did put the link to the GitHub, so just having that as a resource. There's SQL queries in there, as well as Ruby scripts for just some different things that our support team has seen some of our clients do and thought that it would be useful to kind of share with the wider audience. We got another question with where are the template sequels available? I'm guessing it might be related to that library that I was showing earlier. I think it's up on GitHub. It'd probably be a good idea. I'll take a double look in there and just put a transportable database with those kind of factory SQL queries together. Of course, you could always email us too with our contact information there for being able to pull in uh, for us to be able to send those queries to you. Um, Got another question about inputting I to the model. Like I mentioned when we were talking about the calibration piece of things, we do have the traditional RTK method, so having a short, medium, and long-term response of the inflow and infiltration. We also have what's called the ground infiltration model. That ground infiltration model is a little more physics-based, using properties of the soil and infiltration rates and different things like that. It can be a particularly more accurate for areas that see variable groundwater tables. And Of course, there's going to be more inputs with that. So there's kind of a balance there in terms of whether you really need that. Kind of the same decision that we were talking about earlier with the steady state versus EPS kind of thought process there. But that kind of relays us into the next question of what's the difference between a steady state and an EPS run or extended period simulation. A steady state is um, uh, basically what that means is it's just constantly running a flow through the system. It's much more simplistic. It doesn't take into account storage that's inherently in the system, and because of that, that's where we see some of those oversizing of the infrastructure. With the EPS run, it is taking into account storage and different things like that to be able to really more optimally size the system. Joseph, I know you have experience with that with the potable water side of things. I don't know if you wanted to add anything.
Yeah, no, it's quite similar as well on the drinking water side with steady state and EPS. And really, the trend is going towards EPS for the, the benefits and the the optimized approach that you can take with EPS over steady state. And that actually is going to be the, I guess, the conclusion of Q&A at this point, because I'm seeing quite a few questions that we haven't tackled. So please feel free to email us directly with any of your follow-up questions. And with that, we're just gonna conclude our portion of the webinar. We're gonna transition it over. So thank you all
All
once
right.
again for attending, and we're just gonna transition now.
All right, this was great. Thank you so much. This actually concludes today's e-showcase. Thank you all for attending. The recording will be available at webfiresguide.wef.org. We will send all registrants an email tomorrow with that link. And please visit our event calendar to sign up for future webcasts. And again, if your question was not responded to in the chat during Q&A, you can reach out to the presenters, or they will reach out to you once they get the chat transcript. Thank you so much for joining us today.